Hey, what's going on YouTube? This is Elliot and I am back with you for our final video in our Proxmox to production build where we're building our Kubernetes cluster that will eventually host our AI networking agent. So a quick recap of just where we are and what we'll cover in today's video. Here's a look at our overall build. We have a K3s cluster here, which is running on my Proxmox server with our vault that handles our secrets. And we did all of that last time. We set up our Longhorn blockchain storage as well as our MetalLB load balancer for the services there. So the pieces that we're going to be adding today are going to be our ChromaDB, which is going to act as our vector knowledge store or the agent's knowledge store, and a Cilium network policy that locks down exactly what the agent namespace is allowed to talk to. So let's talk about that ChromaDB first and exactly what it's going to do for us. It's, like I said, a vector database, and we're going to ingest our networking corpus. Now, what that means is I have a lot of OSPF documentation and references. I have some BGP troubleshooting guides and decision trees. I have some design pattern documentation in there. And by putting all of this in our store there, we're basically creating a pipeline, an ingestion pipeline that converts each document into chunks. And then it's going to generate vector embeddings using the 1024-DIM BGE large. Now, I'm not going to get into what that is and all the technicalities of that, but it basically breaks down our documentation into chunks that the machine can read, and then it's going to store them in the Chroma database. And the reason, or the reason why we need this is because when the agent needs to reason about a problem that it has within the network, it's going to need somewhere to look. And so we're going to create this so that the agent looks here. This is going to be where the most relevant knowledge pertaining to our network is going to live that our agent can call. And the last thing to remember here is that it's backed by our Longhorn persistent volume, so that if any one of these workers or the data, the volume restarts or gets crashes or anything like that, the data is going to persist and will survive in our ChromaDB here. So now on top of that, we're building our Cilium policy, and this is the security piece. So by default, Kubernetes can talk to anything, whether it be the internet, other namespaces, whatever. And that's not acceptable for an agent that needs to SSH into network devices. So what we're going to do is we're going to deploy a Cilium egress policy that whitelists exactly 5 things that we're going to give our agent the capability to reach. That's going to be DNS for name resolution, the Anthropic API key so that the agent can call Claude. We're going to give it the access to our ContainerLab VM for SSH access to our lab devices. And we're going to give it access to the ChromaDB for that knowledge retrieval. And then we're also going to give it access to our vault for the secret injection, because that's where our API key is stored. So everything else is blocked, as you can see down here. And it kind of has a drawing here of how the data flows and what our agent here, the namespace, can reach. It can only reach these, the vault, Anthropic, the VM again, and DNS, and everything else is blocked. So basically, if our agent ever gets compromised or, someone tries to exfiltrate data from there, the Cilium policy that we're going to implement is going to stop it right there at the network layer. So to tie it back all together, the way that the flow is going to work is that our agent pod is going to start up, okay, and then the vault is going to inject the API key, and then our agent is going to query the ChromaDB, all right, for any relevant knowledge that it needs. It'll then call out to Claude, all right, and then finally it'll come back and SSH into our devices to gather the state. So, Cilium ensures that, only the things that, the network is allowed to do, it can do. So that's basically defense in depth. All right, so I just wanted to give everyone a quick recap of where we are and kind of what we're building toward. Bear with me a second here. I'm going to move my screens. So the first thing that we're going to do in today's video is we're going to get our ChromaDB set up. We're going to go ahead and deploy it. And the way that we're going to do that is we're going to deploy it with 3 different manifests. Okay, the first is going to be a PVC. Now remember, that's a persistent volume claim that requests 10 gigabytes of Longhorn storage for the vector data, right? And then we're going to set up a deployment manifest that runs the Chroma database container and mounts that storage. And then finally, we're going to deploy the cluster IP service so that other pods in the cluster can reach it on port 80, or I'm sorry, on port 8000. So now I'm going to copy and paste these because I'm basically just writing a lot of, well, you'll see here. We're creating a lot of files here, and our indentation is the key here. So what I'm going to do is just go ahead and make sure that I copy and paste to make sure that we don't run into any problems. So the first one, like I said, is going to be the PVC that requests 10 gigabytes of storage from Longhorn. So as you see here, we basically, it's the API version 1. We're doing a PVC. We're naming it ChromaDB data. We're going to give it the namespace, our namespace agent. We're giving it the ability to read, write once, and it's going to be in our storage class of Longhorn, and we are going to request 10 gigabytes. I'm sorry. Okay, so the next manifest that we need to create is a deployment that runs the Chroma container and mounts that storage, mounts this 10 gigs. So give me a second here. And all of these commands are going to be in the GitHub repo that you'll be able to use. I'll show you real quick I won't show you, but you'll see when you go to the GitHub repo, I actually have a HTML and PDF files that you can use that have all the steps and all the notes and gotchas you need to watch out for. So, like I said, back to it, we've gone ahead and we've created our PVC, and now we've gone ahead and created our deployment. And as you see here, this is for our, we have a deployment, ChromaDB agent namespace. The app is ChromaDB. This is the image that we're using, the latest image. We're going to be on the container port of 8000. This is our path. We requested 512 megabytes for our RAM and 250 megabytes for the CPU. And then we set the overall limits of what it can run. And then, of course, like I said, we want this to be in the PVC claim that we just created, which is ChromaDB data. So we've now bound those two together and linked them. And then the last piece for deploying ChromaDB is to establish the cluster IP service so that all the pods can talk to each other on port 8000. So let me come here. Okay, and so our service has been created. Like I said, those are all good. And the next thing we can do, let's go ahead and clear, and then we'll verify that ChromaDB is actually running, that the pod is healthy, and then we'll even spin up a temporary curl pod inside the cluster so we can hit that heartbeat endpoint. And if we get a response, then we know that the database is up and reachable through the Kubernetes service discovery, all right? So what I'm going to do here is I'm going to say kubectl minus n agent get pods minus w. All right, the pod is up, it is healthy. We are good to go, it is running, all right? And now let's go ahead and test the API from inside the cluster. So I'll say kubectl minus n agent run curl dash test dash rm, because we're going to remove it when it's done, yeah, just one dash it / we'll say dash image equals curl images / curl and dash restart equals never. // Okay, and then we'll say curl -s http going / ChromaDB port 8000 /API /version 2 /heartbeat. I made a mistake. Go back here and put the T on my agent instead of typing it all out that time. All right, great. We got a response and our test got deleted from the namespace, which is what we wanted. Perfect. Okay, so now we can go on to step 4, which is the Cilium network policies. And they're going to lock down, it's going to lock down the agent namespace so that pods, like I said, can only reach services that they need. And this is going to enforce the least privilege egress that's aligned with the OWASP agentic security principles. And, if you're not unfamiliar, you can just Google OWASP agentic, security or something like that. And then you'll see I think there's 10 rules or guidelines that they suggest that you use if you're going to build agents. And I believe it came out in December, just a few months ago. So it's fairly recent. But anyway, so let's go ahead and apply our network policy. And now this Cilium policy is a whitelist. So again, it just defines what the pod can do and who it can talk to, and then everything else is going to get dropped, okay? So I'm going to go ahead and copy and paste. This is just one long policy here. Give me a second. And we'll copy it, and then we'll kind of go over it. Let's clear our screen. Okay, so again, this is just our Cilium policy. It's a Cilium network policy. It's going to be named agent egress in our agent namespace. This one here for the egress, we're going to allow DNS to these labels within our cluster here to ports 53. So of course that's DNS. Then we got one to allow Anthropic and all that good stuff. So we are going to go ahead and run this. It just tells all the ports that it can reach. Okay. So the namespace, the policy has been created. So now let's go ahead and, let me call out one thing. If you run this yourself, this right here, this is the IP address to my VM in my pod that hosts my ContainerLab devices. So if you're setting this up and you're hosting your own VM somewhere, just make sure you switch out the IPs for your IP. You can leave the same ports and all that good stuff, but just switch out the IPs there. All right, so now let's set up do another test to make sure that this is all working. And what this test is going to prove is that our policy is going to work. So we'll deploy a pod with the agent label. Then we'll try 3 different requests. The first request is going to be one to hit Anthropic, and that one should succeed, although you'll see we'll get a 405 error message because we're doing a put and not a get request. But anyway, we should get that request back from them. The second one is going to be to Google, and that one should not succeed because Google's not on my whitelist, so that should fail. And then the third one we're going to set up to ChromaDB, and that should succeed as well. So let me come here, and first we'll input the test here. Okay, so our pod and our policy, it's pod/policy test, and it's been created. Now let's come here to make sure we're going to run this command, this kubectl command, to make sure that the conditions for the test are ready. So it should return condition ready or condition met. Okay, that's what we wanted there. All right, now, and I'm going to type the tests themselves. No, what? No, we're not. Now let's go ahead and test our Anthropic API. And this should succeed because Anthropic is allowed, and I have my API key in the vault. So the vault's going to inject it via sidecar. So let's go ahead and put that here and see if we get a message. And we do. We got that 405 back, which is what we want to see. That's good there. Okay. So now let's test whether or not we can reach Google. And we should not be able to, so this should time out. Perfect, all right? So the command was terminated because Google's not allowed, and that's exactly what we expect, okay? And next, let's test to make sure we can reach that heartbeat in ChromaDB. And perfect, there we go. We got the heartbeat there with the verification. So we're good to go. We know that our policy is working. The cluster can reach what it's supposed to and what it's not supposed to. So now let's clear this, and then I want to clean up. Clear it again. Why is that? Yeah. Okay. So let's let me kubectl. I want to remove that. So dash in agent delete pod policy test. Oh, delete pod. And the right command, Elliot. All right, so it's deleted from the namespace. Give it a second. Sometimes it takes a while. Well, we'll just Control-C. It's fine. Okay, so now that we've done all that, let's do some end-to-end validation just to make sure that all the components of what we've set up this entire series are working. So we'll just do one final sweep. We're going to check that every node is healthy, that every pod is running. We're going to check the Longhorn has our volumes. We need to make sure that the vault is unsealed. Some of this stuff we know. And then we need to make sure that ChromaDB is serving and that our network policies are in place, okay? So we'll just clear here. So let's check the cluster nodes first. We'll say kubectl get nodes. Mine is, or dash 0 wide. So that's O, not 0. Okay, perfect. All of our nodes are up and ready. Here you see they've been up for 3 days now since we first set them up. All right, they're good to go. Now let's make sure that all the pods are across all namespaces, okay? So we'll say kubectl get pods minus capital A. Okay, so as we see, we got our agent namespace, we got ChromaDB, we got Nginx, which we set up in the first video there, we got our Cilium set up here, we got our core DNS there, good. All of these good. Longhorns, good to go. We got Metal LB and we got our vault. Everything is up and running. That's perfect. That's what we want to see. All right, so now let's check the Longhorn volumes themselves. So I'll say kubectl -n Longhorn dash system, and we'll say get volumes .longhorn.io. And what did I run? I put a 0. Okay, there we go. Our volumes are attached and they are healthy, okay? Good deal. All right, now let's check our vault status. Let's clear again. So yeah, let's check the vault status. It should be unsealed, or should be, yeah, unsealed. So sealed should show false. Try to say that real fast. So kubectl -n vault exec vault -0 -- vault status. Okay, good. Our vault is unsealed and we are good to go there. All right. Next, let's check the health of ChromaDB. So we'll say kubectl -n agent get pods -l app equals ChromaDB. Perfect. ChromaDB up and running, good to go. And then finally, we'll check our network policy. So we'll say kubectl -n agent get Cilium network policies. And there's our policy agent egress, and it is valid and true. So there we go, guys. We are good. Like I said, that whole thing, everything is up and running. So phase 2 of my build is complete. The first phase, which we didn't put on camera, which is simply just setting up my Proxmox server and getting it up and running. That was done. Phase 2, which you all have seen, we have implemented our Longhorn storage on our pod. We have our HashiCorp Vault set up. We have ChromaDB for our agent. We have our network policies, and we have an agent service account as well. So the cluster is ready to receive the agent application now. And in the next phase, we are going to deploy the Fast API agent backend. We're going to wire up the secret injection for the vault, and then we're going to connect to our ContainerLab devices and run our first autonomous troubleshooting session. So we got a lot more in store, but thank you so much for coming along with me on this build and getting the lab up to this point. I appreciate everyone and everyone that's commented and liked the videos. And if you want to see more, you can go to my website, www.thetech-e.com. And you can also go to my LinkedIn. You can just search for me at Elliot Connor on LinkedIn. And yeah, you'll find me there. Both of those places you can find access to my GitHub repo. Again, all the information for this build will be in my GitHub repo, and I'll put that link in the description. So please like, please subscribe and follow. I appreciate everyone, and I will see you in the next video. Have a good one.